Hello guys, how are you? Welcome back. Re tswalla ka go solve dipotso under topic ya rona ya gas laws. Re simolla ka question number 1. A given mass of nitrogen has a volume of 3 times 10 to the power negative 3 meter cubed at a pressure of 50,000 pascals. Determine its volume if the pressure is increased to 60,000 pascals while the temperature is held constant. So data re ka simolla hela ka go ene go ikwala. Again, what is it we have? We have V1, that is at the beginning. Volume ya rona ke yone again ke 3 times 10 to the power negative 3, and then P1, pressure at the beginning, because this is volume at the beginning and pressure at the beginning, and that is 50,000. And we also have V2, not V2, I'm sorry, it's actually P2, right? P2 is 60,000, and we are to find V2, volume at the end, question mark. So what do? We are going to use PV is equal to constant. So P1 V1 is equal to P2 V2. You're on a Boyle's law, okay? So pressure ke bokae? 50,000 times V1 ke mang? 3 times 10 to the power negative 3 is equal to P2 ke mang? 60,000 times V mang? V2. Yes, let's compute this. So I multiply 50,000 by 3 times 10 to the power negative 10. Okay, this value is 0.03, right? 0.003. So around 150 is equal to 60,000 V2. From here, what do? We divide both sides by 60,000. 60,000, right? This into this cancels out. Then here 1. We are in now okay. In 0.0025. Yes, that's V2. Or V2 is equal to 0.0025. So re ka ikwala in scientific notation ya la ka ile volume ya nngwe la ke ra re nna not this. V2 is equal to 2.5 times 10 to the power negative 3 meter cubed. So ke yone answer ya rona. Yano number 2, number 2. Number 2 an air bubble rises from the bottom of the swimming pool to the surface. At the bottom of the swimming pool, its pressure is this. Date. Okay, it's starting from the bottom again. P1 is equal to 125,000, and upon reaching the surface its pressure is 98,000. go ra re P2 go bohelong a ke bokae 98,000. Determine the volume of the bubble at the surface if its volume is 3.8 centimeter cubed at the bottom. Go ra re volume ye ke ya kwa tlase ya ka pressure ra go ra re ke V1. V1 is equal to 3.8. Yana re batla V2 once again. So formula ra ke ntse ke yone P1 V1 is equal to P2 V2. P1 ke mang 125,000 times V1 ke mang 3.8 okay, is equal to P2 ke mang 98,000 times V2. Wa bona re go hana ga ke change di-units tse 3.8 ke mo tsenya ntselana ka re batla volume gape go ra re volume re yang go e bona ya go tswa ile di-units tsene tse gape ke yaanong a re computing. Okay, this value times 3.8 gives us 475,000, which is equal to 98,000 V2. So we divide both sides by 98,000, right? Both sides by 98,000. This cancels out. Q11. This one. What do we get? K 4.8469 timer. So V2 to how many? Two significant figures. Got a volume nearly two significant figures. Okay, what are then 4.8 centimeters centimeter cubed. So ke tla ra khona go bona gore ka gore pressure ra P2 ile kwa tlase V2 tshwanetse re kae ye go godimo. Okay, because they are inversely proportional. Yeah, Arabone question number 3. Well, here is question number 3. An air bubble rises from the bottom of the lake to the surface. The atmospheric pressure around the lake is 95,000 pascals, and the volume of the bubble at the bottom is 3.2 cubic centimeter, while at the surface is 10.0 cubic centimeter. Calculate the pressure inside the bubble at the bottom of the lake. Yes, the pressure inside the bubble at the bottom of the lake. Yeah, I require data, guys. First things first. So bottom is bottom again. V1 at the bottom is equal to 3.2. At the surface kodimo ke bokae ke 5.0. Okay, yes, ke 5.0. Yeah, the atmospheric pressure around the lake is this much. Okay, horare ke go godimo. Ke go godimo. I go godimo horare ke P man P2 is equal to 95,000. Yana about the P1. Yan P1 ya guys, se se botlhokwa se ntse re se lemoge ya ke gore the pressure kwa tlase kwa gore is due to water and what? And the atmospheric pressure, because bubble highly what is on top of it? It is the water and air. Air right atmospheric air. So P due to water plus P due to the atmospheric pressure. Yes, this is what we are going to calculate. P1 is equal to P1 V1 is equal to P2 V2, right? So P1 times V1 ke mangana ke 3.2 is equal to P2 ke mang 95,000. So you put the assumption you the temperature is held constant. Larissa mention, but it has to be constant. Yes. V2 man 5. Yeah. So routing 3.2 P1 is equal to 95 times 5. 95,000 times 5. And now 475,000. So after this step, what do? We divide both sides by 3.2. We divide both sides by 3.2. Right? This cancels out. Then we divide this by 3.2. And what do we get? P1 is equal to 148,437.5 ke P1. So rare pressure raro na ke yone aga 14 make bane le rene le 148 to 3 significant figures. So almost these 3 significant figures. Yeah. Given a P1, the pressure inside the bubble at the bottom of the lake. But this pressure is due to what? Water plus atmospheric pressure. So BR calculate the depth of the lake. The depth of the lake the pressure due to the water only. So this is part B. 148,437.5, right? Minus atmospheric pressure. Yes. Okay. So P1 is equal to P water plus P naught. So to find this, we subtract P naught from P1. And what do we get? This is what we get. 53,437.5. This is PW, and this is equivalent to rho GH. Rho GH. Rho GH. So rho GH is equal to 53,437.5. And what do we do? Ra substitute density of water 1000, G 10. So P ke rho ke 1000 times G, which is 10 times 10, H ke ne re matanga ke that is equal to 53,437.5. So go ra re mo e nna bokae? 10,000. So 10,000 H is equal to 53,437.5. What do we do? Divide both sides by 10,000. Divide both sides by 10,000. This cancels out. And when we divide this by 10,000, this is what we get. 5.3437.5. H is equal to 5 point 5.3 centimeters or meters. Both. Well, re ka ipotsa meng hela a re lemogeng gore density it is in meters. Mo formula reng a gona re kileng ra kopana le di-centimeter teng. A kere a gona gore kopana le di-centimeter teng ke di-meters ke itse. A kere this is in meters. So ke gone ha e tla nna 5.3 meters. Ile yone the depth D is equal to H is equal to 5.3 meters. Yeah. So these are the questions that I wanted us to look at. This one is our Boyle's law. PV is equal to constant. I get PV is equal to constant. It's on it. So thank you guys. Let's meet on the next lesson.